This is GACE 023, number 14. This was a strange problem, I thought. You're answering this question by clicking on the correct response, and they want you to find out what is an expression that's equivalent to this side, okay, the unlabeled side. Now, interestingly enough, I want you to notice something right here. If you have A right there, okay, and then there's another A right there, you do know that A is half of B, or two A's make a B, okay? And so they kind of capitalize on that. They go, okay, first of all, if you are to take this whole length, B, so let's just back this up. If you take the whole length B here, and then you subtract out C, would you end up with that unlabeled side? So yes, you would. Keep in mind we're looking for something that is not an expression. Okay. The next one is, it says if you take 2A, well, keep in mind we just said that 2 A's make a B. Okay, and so if you take 2A minus C, that's the same as just substituting 2A in for B, so that's also true. Okay, if you take 4B, okay, 4B would be the distance, this distance and this distance doubled, okay, and subtracted 2A, so 4B minus 2A is the same thing as 4B minus B, which would be 3B. I don't see any reason why that would work out, but let's just double check the others. Now, if I took 4A and subtracted B, okay, so 4A, 1, 2, that would be 2B, okay, so you could call this 2B, and you subtracted B, and then subtracted C. 2B minus B is 1B minus C, which means yes, you can use that one. So the answer is the third one. Now I want to tell you that when I first saw this question, I kind of just didn't see it that way because I was looking at why would you do 4B minus 2A? And so I did recognize that 2A's made a B, but that's about it about this particular question. And so let me show you what I did. I took this, let me get some grid paper back here, and I just made a theoretical graph of this, and then I try not to use numbers like 1 and 2. I use numbers that are slightly bigger, so I said just so that 1s and 2s, sometimes when you're just testing with actual numbers, strange things happen that wouldn't ordinarily happen. So what I did was, I'm going to draw here. I said, okay, I'm just going to say that A is 5, okay? 1, 2, 3, 4, 5. All right. And then I'm going to say that B, well, B has to be 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so B is 10. It doesn't tell you how much C, so I just made up a number. I just said, okay, I'm going to go down 6. 1, 2, 3, 4, 5, 6. And then remember, this is A. We know A is 5. And then you have to go down and meet this bottom part here. So this is B equals 10. And this is A equals 5. And this is C equals 6. So these are just hypotheticals. I'm making sure that I have, like, if it says A, then it's the same for every A. And if it says B, it's the same. My hypothetical shows a 10 for each B. And also that the A is half of B, okay? So then I just looked at these expressions and said, okay, B minus C, that would be 10 minus 6. And by the way, let me just go back here one more time and just say, I did figure out if C was 6, this is 4. So what I'm looking for is, does this work out? B minus C is 10 minus 6, which is 4. Yes. Moving on, 2A, so 2 times 5, minus 6. Is that equal to 4? That'd be 10 minus 6. And that is, in fact, equal to 4. Check. 4B, so that would be 4 times 10 minus 2A, so 2 times 5. So 40 minus 30, that equals, no, sorry, 40 minus 10 equals 30. Does that equal 4? No. And let me just double check this last one now. 4A minus B minus C. So 4 times 5 minus 10 minus 6. So that would be 4 times 5 is 20 minus 10 minus 6, which is 10 minus 6, which is 4. Check. So with hypothetical numbers, that's a second way to approach this if you're kind of lost on what it's asking. And as long as you follow the rules set up in the problem, your hypothetical numbers will generate for you whether these are equivalent expressions or not.